Alright, hey guys, welcome back to another online lesson where we're going to be looking at an informal way of finding the critical path for our activity networks. This is pretty much all you need to do to get achieved if you're able to use the precedence table, draw the activity network, and then find the critical path and state the correct path and the weight of it. You will be able to get achieved in the standard. Tomorrow or the next day we'll have a look at actually using a formal method of finding the critical path using a forwardance method, which you'll see later. But for today we're just looking at an informal method, which is just kind of using your eyes or calculating every length of the path and finding the longest one. So for achieved, you need to do, from a precedence table, draw the activity network, as I said, and put on the durations of each activity, which we haven't done yet, but we'll do today, and then find the critical path. We are now going to look at how we can find the critical path informally, like I said, and later we'll be back to look at formal ways of finding it. Okay, so what is the critical path? The critical path gives the activities that must be completed on time for the project to be completed without delay. The ASAP time is what we like to call it. It's the path that holds everything up if it is delayed. So if one part of this path is delayed, you can't finish the project. You gotta finish this part of the project before you can finish the rest. So the critical path is usually is the one that takes the longest time. It's the longest path. The critical path is the longest path. Important to remember. Alright, so consider that you're going on a camp. The bus can't leave until everyone arrives, so you are dependent on the arrival of the last person. So the earliest you can leave, so the ASAP time, is when the last person has arrived, for the longest or latest time. So if someone rocked up 5 minutes late, still can't leave, you gotta wait till they get there. That's a good example of what the critical path is and what we mean by the longest path. Alright, so here's an example. I'm going to switch to OneNote and try and work through it step by step with you, and then adding the durations, and then I'll come back to this PowerPoint and see how we went with the answers. Okay, so here's my precedence table. This is pretty much what your achieved questions will look like. Is you'll have this table, you have to draw the activity network, you have the durations, and you have to find the critical path. So what we do is we start with our source node, and then we need to figure out how many paths come off that or activities come off that, and in this case it's just one. Yeah, so we've just got the activity of A occurring, so let's just put that there with A, and then I'm going to put another node in here. Okay, so from A, what happens? What is dependent on A? So B and C and D is dependent on A. So I'm going to copy this and paste it 3 times because we need 3 activities coming off that are dependent on A. Just a bit like this for now. I don't actually know what it looks like, so I may have to adjust this a little bit. Alright, the next thing that happens and is dependent on B is E. So if we put another node in over here, I didn't label it. Let's call the top one B. What's the next letter? C and D. Cool, and so from B we have E, the activity E that is dependent on it. So we've got E there. Ooh, for some reason it decided that it would shuffle everything down. Still did it. I'm not sure why, but there we go. Okay, that's our E. Having a look at the next one, our F is dependent on D. So I'm going to get another node because off of D, and that is going to be F. And then from, I've got to add F there, but from after that, we got two things coming from C. We got G and H, two activities. Alright, so I just readjusted everything so it fits from left to right in time of when the events happened. And so we've got our next, after C was G and H, so we'll just add in G and H. And then what is next? G, H, so I is dependent on E and G. So we can extend these ones to meet to become I. And then J is from H and F. I'll just continue this one out. Just randomly put it up there. And this was called J. And from J comes, from I and J comes K. So these two mix. Actually, I'm going to adjust this a little bit. And adding my source node to the end. Oop. Oh, not quite my source node yet. I still need to add my K. Alrighty, so now once you've drawn your network, you can go back and add the duration of each activity next to it. So I'm going to just put them in brackets. So for the activity of A was 5 days, activity of B was 3 days, activity of E or C, let's do C, was 5 days, and then D, and so on. Alright, so now we have all the durations of the day, and so our next step is to literally find the longest path. So from A and to get to K, what is our longest path to get there? So you could try the top one by adding them all together, try the middle one and up this end to the end, middle one and down to the end, this one all the way down to the end, and find the longest path. So I'm going to switch back to the PowerPoint because it highlights it really well there, but that was just to go over how to draw your activity network from a precedence table and then just adding the duration to the things. So let's see how we went. So ours looks pretty similar to that one, I'm pretty sure. Just flick back. Yeah, mine's just slightly thinner. Cool, so it's good to know that we're doing it correctly. And so from here, we can go ahead and find the longest path by just looking at the paths and adding them together, like I said before. So a highlighter does come in handy here because you can just go along and highlight the path that you're looking at, and then you can write it down the bottom and see how many days you could do. So for this path in particular, going from A to B to E to I to K, so it's important to write down the path that you're actually taking and then write down the length of each path and then add them all together. So this one is 21 days. I don't think it looks like the longest longest path, because I'm assuming we're going to have to use H in here or F here because they've both got 7 or 6 days. So let's have a look at the next path. So A, C, G, I, K. It's 22 days, so that's already longer, so definitely not going to be the first one. Having a look at the one through the middle going the low road, going down this way, we've got A, C, H, J, K, gives us 24 days. And I think the last path to check is the bottom one from A and down and across is 22 days. And so we can see from this that our longest path was the middle one, right? So it was A to C to H to J to K, which gave us 24 days. So what we need to do is we need to write this out saying, so the critical path is the one in red. This means the earliest project can be finished in the ASAP time of 24 days. Sweet. If any of these activities take longer than the time stated, the whole project will take longer. Yeah, so that's like, say for C, if that was delayed by 2 days, the whole thing would be delayed by 2 days, because you can't finish any of these until this one's finished. And they're going to be the longest projects. So until this one's done, if it's delayed by 2 days, it's going to delay the whole thing by 2 days. Same with this one. If this was delayed by 3 days, these two would then be delayed by another 3 days, as in it'll be 3 days after these before we can even start these ones. So that's what this is saying down the bottom here. So the activities that aren't in the critical path can fit in around these critical activities. So you can kind of manage the other activities to make sure that they're all done by the time all of them are done. Alright, this is a practice one for you that I'll put on Teams for you to practice with and have a go at yourself. And once you've had a go of it, you can come back to this video and have a look at the solution. So your activity network should look something like this with the weight of it, and your ASAP time would have been 26 weeks, with your critical path being A, E, F, G, and I. And any of these activities take longer, then the whole project will take longer. And so that's a quick little example of an achieved solution from this table back here, this precedence table. Okay, I'm gonna go through the next one. This one, have a go of yourself, pause the video here, draw your activity table, and then you can come back for the solution, which is this. And you can have a look at that, see how you went, any mistakes. Your ASAP time would have been 12 days. Critical path is A, F, H, J, K. If any of these activities are delayed, the whole project will be delayed. Alright, and last one, pause the video here, have a go of this one, see if you can find the critical path or the ASAP time. And here's one more, see if you can do it. Alright, thanks guys.